Hello, everybody, and welcome to this track on our session on robotics and drones. I'm going to talk about robotics mainly, and my name is Søren Tranberg Hansen. I used to be working in research. I'm actually a computer scientist, and a couple of years I worked as a system developer, and then I changed into research and worked as an industrial PhD for a couple of years on robotics. And now now I work as a consultant for the Ministry of Foreign Affairs, something called Invest in Denmark, not related to robotics so much, but still I work with IT companies. And I also I recently published a book on robotics. It's in Danish, and it's not a non-tech book, but it's a kind of an overview of what's going on the robotics scene, and that's pretty much the basis of what I'm going to talk about here. So it's not I'm not going to go into depth as the former speaker, but I'm trying to give an overview on the business side and what is going on the robotics scene in general. So yeah, click engage and rate the session. So first of all, yeah, this is what I'm going to talk about. Just setting the scene. What is actually a robot? It's harder to define than you would think, and we'll give some examples of what is happening within this area, and I'll also give some tips and tricks on how to make your own robot project and what are the toolbox you can use. So just to zoom out a bit, because what is a robot? Yeah, there's 100 of definitions. There's a lot of definitions, and depending on what definition you take, you can actually use. You can say your washing machine or coffee machine is a robot because it has some actuators and there's some programming. So the mere fact that we don't have that we're maybe not talking about the same kind of machine makes this whole area a bit troublesome to make some good tools, because of course it's different if you want to program for this type of robot or this type of robot. They're all robots, but yeah, very different devices. And this is just an overview. I mean, we have the humanoids and we have this industrial that we saw before. We have logistic robots that drive around, and drones also, and they're applied in different sectors. So it's a very broad range of technologies. But nonetheless, there's a lot of hype about it, and the amount of robot companies that are coming out right now is increasing. And some of the traditional IT companies are also looking into this area, most notably Google. So people in the sector talk about before Google and after Google. Before Google went into robotics, it was all R&D, or mostly R&D, and some startups, and some big companies like KUKA and ABB. But within the last 5 years or so, 5-10 years, we see these companies like Google and Cisco, traditional IT companies, they're moving into the sector, and that's changing the whole scene a lot. So if you're an app developer, maybe you should think about robotics also as the next big thing for whatever that is. One funny thing I found out was that Disney is also going into robotics. So what the hell is Disney doing in robots? And we're going to see now what they're doing. Fantastic. So I actually met these guys who are developing this in Boston last year, and they had a project called Spiro, which is also kind of an app-based robot. And they're just young guys, and I don't know how they managed to get a deal with Disney, but it's kind of an app-based product, and they use some of the facilities for augmented reality and voice recording and all that. So it's an extension of a traditional app. Oh, sorry. You don't want to see it again. Right. So, so what is all the hype about? Why is robotics exploding right now? And some of the reasons is that we have some new techniques for handling big data, or a lot of unstructured data that we didn't have before. So you probably know Watson and DeepMind and these projects. And also there's been a paradigm shift about robotics. Normally you would think about them as a closed entity and they should solve everything by themselves with their own sensors and processors. But now we are more talking about networked robots and robots that are able to communicate. For example, the autonomous car. So and then of course price is falling and on the sensors. And there's also some tools. We're not good at making tools yet, but there are some. And this is just, I guess you're all familiar with Moore's law, but this robot at the left, my right-hand side, your left-hand side, the yellow one was made by Mitsubishi for some 10 years ago. And this Pepper will come out. It is actually out in Japan already, and it's only $2,000. So, I mean, prices are falling, and it's going to be... that was just completely unrealistic 5 years ago. But now it's here, and we see it in a lot of sectors. We see it in the industrial sector. These are the traditional industrial robots and universal robots we saw already. And we have Baxter, 2-armed robot with a head. Yeah, it's not a joke. It's out there as a product. And we see it in logistics also. A lot of new transportation robots coming out. This one is also, it's a Danish product, which is going to be really cheap. And Kiva, a small project that Amazon bought for like $700 million or something. And in health, we see it in surgery, and this Paro, I guess, at least in Denmark, they're quite famous. It's a robot pet for people who are demented. So yeah. And of course military, they're driving a lot of the development, drones and these packbots. And so they're pressuring a lot, and they're pushing the technology a lot. And some of the newer stuff that is coming out is
this is your house.
Personal
this
robots.
Is your car. This is your toothbrush. These are your
Indiegogo
things.
project.
But these.
So this was an Indiegogo project, and she managed to get, I think, $3 million, and then some additional investors went into it. And she's a researcher at MIT, and I guess you followed her also, right? Yeah. So she's been working with this for many years, and now it's a company. But what is it? It's actually a tablet inside a device, and it can move around. And there is some evidence, research evidence, that this actually has some effect on people on the way you perceive it. It changes a lot whether a device can move or not. So that's kind of that effect he's using on this. And there's a lot of stuff going on right now. If you just spent, this was just something I found actually yesterday, looking at personal
Meet
robots.
the world's first artificial intelligence personal robot.
It's very ambitious, I think. But so let's see, it's running right now, the campaign. Yeah. So there's a lot of stuff going on in this area.
Also, 82% of people living there have a college degree.
I think that's the right one for us.
I'm not personally convinced that this was ever going to work, but I'm also biased because I used to work as a researcher, and we could not make anything work at all. So we tried a lot. But what is happening is that we get a lot of new development platforms. So this Turtlebot is a open source and open hardware project you can buy, and these two ones are actually vacuum cleaners that you can use as a development platform also, and the one this one NITO, it's actually a vacuum cleaner with a laser scanner. I think that's really fantastic. Imagine that, a vacuum cleaner with a laser scanner. So yeah, it's a LiDAR, so it can be used for mapping your environment. The traditional robot vacuum cleaners, they were just more or less randomly running around. But now you can actually, it can map the entire room, and Roomba, iRobot's Roomba also have a similar model. And you can connect it, it has a USB, and you can connect it with Raspberry Pi and stuff like that. So for less than, for $800 or $500 or something, you can really get a good start that was very expensive just 5-10 years ago. So it's changing the scene a lot. And Ross is the former speaker. He called it JavaScript for robots. there's not that many software tools out there. We don't have a Visual Studio or anything like that, unfortunately. PlayStation, when I was a researcher, was the most popular, but it's kind of not used so much anymore. It's not active. Microsoft had a robotics studio, but it has not been updated since 2012. So ROS is actually more or less the de facto standard. And some people hate it, and some people love it. It's an open source project by Willow Garage, and now it's maintained by this open source robotics foundation. And it's very, because we don't really know what is the device we're programming for. It's very modular designed. It has to be that way, because if it's a industrial robot or it's a vacuum cleaner, whatever, it's two different things. But so if you need some development tool that fits into all that, then it has to be that way. So you have like a core, and then you plug in different modules, and it also makes it a bit tiresome to work with. But it's there, and it's probably the best platform there is right now, especially because it has some simulators, states and gazebo. And states is if you have a number of robots that you want to simulate, and but with low fidelity, and the other one is high fidelity, but only if you have like 1 or 2 robots. And it also has a really nice debugging tool, so you can, maybe it's gonna speak for itself.
Hi, I'm Josh Faust, a software engineer at Willow Garage, and I'm going to talk to you a little bit about ARvest, our 3D visualization environment. ARvest lets us view what the robot is seeing, thinking, and doing. Developing on a robot can be very difficult without knowing exactly what the robot thinks is going on in the world. Debugging by looking at numbers scrolling by is difficult enough in 2D. Unless you have an intuitive understanding of quaternions and coordinate frames, debugging 3D by numbers alone is not much fun. ARvest lets you look at the world through the robot's eyes, whether those eyes are cameras, lasers, or joint encoders. There are 2 main ways of putting data inside ARvest's world. First, ARvest understands sensor and state information like laser scans, point clouds, cameras, and coordinate frames. These have specialized displays that let you configure how you'd like to view that information. Second, we have visualization markers that let you as a programmer send primitives like cubes, arrows, and lines, colored however you want. The combination of sensor data and custom visualization markers make ARvest a powerful tool for development of robot capabilities and research. The ROS navigation stack uses a combination of these to show its current path, obstacle data, 3D voxel grid, and topological map. ARvest markers have also been used by motion planning researchers to show planned versus actual paths, goals, object detection, and calibration. ARvest is a powerful tool for debugging robot applications. It's free, open source, and available now at ros.org.
So stuff like that is available, and that of course helps a lot. It's still difficult to make good products that actually work, but this is certainly a big help. And you can actually, as a traditional, there's some help if you're an iOS developer or Android, especially for Android. There's a lot of software packages out there. Most of it is run by some university or anything or someone like that. So it's not a commercial product or anything. It's open source, most of it, with the benefits and all the problems it has. But it's out there. If you're into humanoids, this is Aldebaran from France is the leading company right now. So this is I don't know I don't know what you can use it for, to be honest, and I don't think the creators they don't know it either. But now it's there, and there's a lot. It's the small one. The now is used for education, especially, and that's what they designed the software for. So there is a very high-level programming interface where you can drag and drop like Lego Mindstorms. But you can also program Python and C++, and I believe that they make these platforms and they send it out, and then they're kind of hoping for the community, you guys, to take it up and come up with some cool applications, because that's really the platforms are there more or less now, and they're cheap, but there are very few cool applications yet. So if you're interested in this area, that's fairly easy to get access to now. and that has changed a lot also in very short time. So these are just examples of robots that are more or less based on standard tablets and devices. So we have one here. It's a telepresence robot. So it's instead of me coming from Aarhus going to Copenhagen, I could just skip the robot, and it can run around here. And after the session, if someone wants to play around with it for the rest of the day, it's here available. I'm leaving tomorrow, so it's only here today if you want to use it. So you can sit in your hotel room and then join a one of the sessions downstairs. I don't know. It's a possibility. And this one in the middle is the new one from. This is about $2,200 or something. But this one from China, the middle one, is only, I think, $300. So the prices is just really, it's really cheap now. Quite impressive. This is a project. On the Android-based robotics is growing quite a lot right now. And this board, the Yo-Yo board, is available in most electronic stores, and it makes you able to control any device, motors, and everything from a Android telephone. And there is at the web page, it's University of California, I think. You can Google it and find really easy. Then there's a step-by-step instruction on how to make a cool robot out of an Android device using this board. So there's plenty of help to get. So I'll just go through some of the really basic theory on robots, because unlike static devices or normal devices, we have a tablet or stuff like that, the robots are moving around. And that gives a lot of challenges to how to control it. So there's kind of two, the basic paradigm is that you get some sensor input and then you plan what to do and then you do it. But what the classical way is that you have you have a model of the world, and then you make a optimized plan on what the robot should be. And in the 90s, you kind of changed that perspective a bit, so you have more like instinct reaction. The robot just reacts very fast, have some behaviors that it does. It doesn't have an overview of the entire situation. It doesn't have an optimized plan. It reacts instinctively, like these vacuum cleaners. When they bump into a wall, then they change direction. Stuff like that. That works. The other thing also works, but only in controlled environments, because when you have a moving device and then you have a lot of sensors, then you also have a lot of noise. So you don't really know what comes in, and it's very hard to, with traditional programming techniques, it's hard to deal with. So you have the sensor input that you have to navigate around, and so don't mix up traditional programming with robots. It's actually two different things. It's much harder robotics to make it work. This is just it's a complete research area. Like you have user interface and human computer interaction. You also have human robot interaction. How to interact with robots, and there's a lot of research on that. But just one basic thing is, how should a robot move around a person? That's actually what I researched way back. For example, it's very unpleasant if a robot comes in behind you and just looks at you like. So how can you avoid that? You need to have an overview of where are the people in the room and how can you navigate through these people without they being bothered. Just to manage that is extremely difficult because people are also moving around. So how can you make a decision on that? So if I should give some advice based on my painful achieved experience in robotics, is that don't be too over-ambitious. I mean, these guys on Kickstarter who wants to make this robot participating actively in a meeting and stuff like that, I think that's maybe a bit over the top. Less is more. If they can just make it navigate into that conference room by itself, I think that would be pretty good. So you talk about this paradox that hard problems are easy and the easy problems are hard. So just stuff picking up a ball and throwing it that a child 2-3 years old can do, very hard for a robot. Playing chess and optimizing something, optimizing a problem, very easy for a robot or a computer, but not so easy for us. So the things when you work with robots, you often you find out that this just making this robot moving from A to B. Very tough problem, actually. Still, it's not solved completely. It's getting better, but I mean, there's still a lot of research on this in this area. So, but open source is exploding right now. Also, open hardware. But I would recommend, if you are planning to go into this, use a tested platform first. If you can make it work there, then you can also do your own platform. But working on, or at least you need to have a group of different people with different skills. How much time do I have? Like, yeah, okay. On the funding side, it's very good. I think it's actually never been better than it is right now, because EU is putting in a lot of funding in robotics. I have a very ambitious program. And also, compared to just a few years ago, we have the private sector also investing in robotics. So especially the crowdfunding campaigns, you see a lot, but you also see more venture funds and robo-stocks and different kind of business people looking into this area. So it's really hot. There's an EU Horizon 2020 has allocated money for robotics also for entrepreneurs and small companies. And then there's a lot of regional initiatives. Just later this month, there will be started a robotics startup hub in Odense, and I see that happen in a lot of places in the world. So no matter where you are, there's probably some people trying to find out how can we make some new companies in the robotics area. And this is just I have my own personal project where we use this platform. That's why I have it. So it's funded by EU in this fireware program, and there's still some calls open in the fireware. It's the Future Internet project or call, and you need to use some open software that's developed there. It's a good call in the sense that it's not so complex to apply for, and you can apply it as a single person. It's not a good call because it's also you need to use these software packages that they have defined, and they're not especially suited for robotics, but but you just have to do it. So it's kind of a bit counterproductive. And that's why I actually don't have a demo to show today, because I was planning on showing a demo on what we're doing in this project, but I can't. But we're doing it as a hybrid app. So we have with this specific platform, there is a small SDK, so you control it, drive forward and backwards, and turn, and this head can go up and down, and stuff like that. And then we are using Cordova. So we actually, my fellow programmer, he's a freelance programmer. He's been doing web pages forever. So he's using the languages that he's normally using. And the only thing we have from the robot world is that we communicate with this specific SDK on how to control the robot. And then we have this, and then we have some open source vision software from that we're using from the fireware program. So we are trying to create. This is like a telepresence robot. But we are trying to make some autonomous navigation. We're actually trying to make a game out of this. I don't know. That was also the scope of my PhD. So I have this maybe naive understanding that like we have a lot of games on the traditional platforms, the tablets and the phones. I think robot games. That's going to be the new black. At least that's what we convinced the EU. So we're trying to make these physical games with this type of robot that can run around, and you have to solve some task with the robot using augmented reality and other types of vision software. So yes, so that's actually what I had in mind, and. Questions? Yeah.
There's one question asking when will we have human-looking androids with full AI?
Well, full AI. I don't think we will ever have that. I mean, we're getting closer and closer step by step. But if a robot like you and I don't see that in the foreseeable. Not with the type of paradigm and computer technology we are using today. You can get something that is really convincing for a while, but not fully convincing. And I think it's still there's still a lot to do. We will have some more specific applications long before that. I mean, just to make this robot work properly is hard enough. So there's still room for a lot of improvement. Yeah.
Any other questions?
But maybe we can I can just run around here with the robot so you can see it in live in action.
Can I ask a question?
Yeah.
Just wait.
So related to this, but maybe not as a business, there are some very serious people, expressing serious concerns about AI and what it
Yeah.
turn into.
Yeah.
You combine that with robots all over the place, driving cars,
Yeah.
controlling vessels and so on.
Yeah.
Do you have any thoughts on the ethics and implications of that?
Yeah, I have a lot of thoughts actually. I have an entire section here in the book. My biggest concern is right now is on the privacy side, because you don't know whether this robot is filming you right now, and if I control it around, you don't know what it knows about you. So there's some kind of imbalance about what you know about the robot and what the robot knows about you, and these if it's gonna continue like this, we will have a lot of small devices navigating autonomously and in our conference rooms and drones and stuff like that. So I have my biggest concern right now is on the privacy side, and there's a famous U.S. robotics researcher. He calls it robot smog. So he talks about maybe in a few years we cannot be in a park or anywhere public, because you will have drones flying around, and you will have this Star Wars small robot running around and filming. And I mean, that's a major issue. I don't think. Maybe also on artificial intelligence taking decisions, but that's a bit more out in the future. Just right now, I think we have some privacy issues on what can we allow these robots to film, and we need this license plate that the former presenter talked about. I mean, you don't know if this robot does something. Who does it belong to? You don't know. We need something like that, I guess, some unique identifier, so we can track down who has the responsibility for this specific device. So the very tangible stuff, I mean, that it could be solved, but legislation is way behind on the technology as usual. Yeah. I'm just gonna this. Yeah. Yes. On the legislation side. Yeah. Well, I'm surprised how little people know about robots. Actually, I'm a bit concerned. On the drone side, there are people working on that already, but I think in general, legislators and the people in the political system are not so much aware of what is actually possible to do already. I think it's growing. The attention has been growing a lot the last 2 years, especially Singularity University and people like that. They are talking a lot about also these issues, and of course Elon Musk and a lot of other people. So I think attention is growing, but I'm still a bit surprised sometimes. How many times I've been talking about what a robot is. I don't have the number, but it's even in my own organization. Yeah, it could be better, but it's also getting better. So there's still hope for us. Yeah. All right. So just maybe you've seen this already, but this is it's like a Segway kind of thing. It's hard for you in the back to see, but so it's gonna feedback here, but I can move it around. Yeah, be careful. Not very fast, as you can see, but it does work. So what I see from my screen, maybe you can see. Yeah, you can see it here also. And then there's the camera on the back is mirrored down. So if I change to the other camera, then I can see if I'm driving into something. But there's only one app now, and that's the one I'm using. So. But there is a SDK, so anyone can, in theory, take this platform and make whatever you like out of it, and it's not that difficult to get access to. However, you cannot put it on the App Store because it's not it's in beta testing or something like that. So you can only use it for your own projects. But in theory, so the idea is that well, I can show. I have another promotion video. We like that. No, I cannot. No, but I've experienced that it falls over. So I mean, we have a security aspect right there. I showed it for journalists, and it was in my apartment, and I showed it for journalists here in Copenhagen, and it just fell off, bong, filming down at the floor, and then I had to drive 3 hours to go back to my apartment to see what was wrong with it and take it up again. So I mean, when it fails, you you have to you need some confidence that someone will help pick it up. Otherwise, you just if it falls over here in the conference and I'm somewhere else, it's just or steals it. I don't know. I don't know what to do. Yeah, so it's Skype on wheels basically, and it's pretty big in at least in the US. Let's see if I have. Yeah, so this is.
We are in downtown San Francisco. That's where Reddit HQ is located, and there's about 85 people that work out of this office. And we have about 10 people that work out of an office in New York as well. One of those people is a close friend and coworker of mine named Jordan Opplinger, and he is my partner creating original video content for Reddit.
At Reddit, we have a number of different communication channels. We're always in Slack. We're also in email, which is like where scheduling happens and stuff like that. But there was a need to have communication back and forth between our New York City office and our San Francisco office. So the nice thing about the double is like you can just hop in. Nobody needs to accept the call, which is pretty big. It's just like as if you were walking into a room.
Right from day one, it became very clear that it was a much better way for us to communicate. And I think a lot of that has to do with the physical presence that the double robot is able to give somebody when they're trying to participate in meetings or when they actually want to come up to your desk and talk to you.
Something as simple as like turning to face different people really like engages and helps make you part of the actual physical space. Also, raising and lowering the height on it, it's a level of emotion and interaction that you can't get with Slack or email or anything else.
It really changes the dynamic of...
So, yeah, apparently it works really well. At least it works when you're controlling it, it doesn't feel that unnatural. But for the people who are sitting there and the robot is coming, it's a bit strange situation, but I guess you can get used to it. But as the controller, it feels completely natural, walking around, talking to people. So maybe we'll all have one of these in a couple of years, who knows? Right? Okay. One? Ah, okay. I have more videos. I have plenty of videos. Let's look at this one then.
We present a novel robotic platform leveraging smartphone technology that was developed at a cognitive anteater robotics laboratory at the University of California, Irvine. The motivation was to create an inexpensive robotic platform using off-the-shelf components and open-source software, which could easily be built by students, hobbyists, or researchers, yet still be able to perform complex tasks. We believe three main components can fulfill these requirements. First, a smartphone running the Android operating system is used as the onboard computer and sensing device for the robot. The computing power, compact battery, sensing capabilities, communication options, and intuitive programming interface of Android phones make them an ideal choice for robotic onboard computers. Second, an electronic device called a yo-yo, which can link the Android phone to peripheral devices such as servos, motors, and sensors. Last, a remote-controlled vehicle available from any hobby store. RC vehicles are robust, come in a variety of forms, and provide a platform that includes batteries, motors, servos, suspensions, and electronic speed controllers. A prototype Android car was constructed using an RC car, an Android phone, a phone holder, and a yo-yo, for a total cost of less than $400. The Android phone sent PWM signals to the RC car for steering and speed control through the yo-yo, which was connected via USB. Using a laptop computer, we communicate over Wi-Fi to an Android application that controlled the vehicle and streamed video and sensory information back to the computer. Next, we built an autonomous robot based on this approach. We built a base using a sheet of perforated steel and mounted it on an RC car. Infrared sensors were then mounted on this base, and the Android phone was mounted on a pan-tilt unit made with servo motors. Panning and tilting was achieved by sending commands from the Android phone to the servos through the yo-yo. In a follow the leader task, which was a part of an Android programming class, students programmed a leader robot that could be controlled remotely with one phone, and an autonomous follower robot that used OpenCV libraries to visually track an object on the leader robot, as well as avoid obstacles. We also used our platform for a research experiment known as reversal learning in cognitive science. In this foraging task, the robot was controlled by a neural network running on the Android phone, which simulated brain areas necessary for this learning. The robot used local sensing and GPS to learn where resources were located and when to search for new resources as they were depleted at a location. The Android-based robotic platform introduced here is flexible, innovative, and affordable. Depending on the choice of phone and RC vehicle, its usage can range from hobbyist to educational to complex research projects.
Yeah, so it's really cheap to do stuff like that now, and that's what I think is changing the entire scene. The robot I used for my PhD was around $20,000 or something like that, and I could probably do it today for maybe $200 or less. So the mere fact that we have all these devices and they're so easy to use, especially if you exploit the Android libraries and all the stuff that is already out there for the smartphones, then anyone can make a robot for a very small amount. It's just a matter of the problem is, of course, you need to allocate the time and you need to have a killer application. I don't see that many killer applications, to be honest. I see a lot of strange applications, but not but not a lot where I think I really need that. A lot of toys and gadgets and stuff like that. But I think the scene is lacking professional programmers and system developers also to make really good, solid tools that can be used. We're lacking that, so I'm inviting, like the former speaker, inviting everyone here to join this and try to mature this entire area a bit. That would be nice, because it's a bit. It's right now it's hobbyists and researchers mostly, and then a lot of startups are coming up. But still, there's room for everyone to join here. Yeah. So that's kind of what. No, I can't talk anymore now. Okay.